Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So today we continue our lesson on Digital Electronics Chapter 6, Combinational MSI. So what you will learn today is you will learn about a BCD to 7 segment display decoder. So at the end of this lesson, you are expected to know what is BCD to 7 segment display decoder and how to operate the 7 segment display by using the BCD to 7 segment display decoder IC. Let's continue. So the first part of this lesson is about the introductions to BCD to 7 segment display decoder. So BCD to 7 segment decoder, it accepts the BCD codes on its input and provide outputs to drive 7 segment display to produce decimal readout. So in the previous lesson, I already explained to you what is BCD, which is the binary coded decimal. So in this section, the BCD it is used to operate the 7 segment display. So what is actually 7 segment display? So 7 segment display is a type of display which is usually used in your calculator or in other type of applications. But in this example, I show you how it is used inside a calculator. So in the calculator, each digit is displayed as 7 segment display. For example, for number 8, you see that the number 8 has a total of 7 segments. 1, 2, 3, 4, 5, 6, and 7. So each and every segment has been switched on to display the number of 8. And thus, because of the number of segment is 7, it is called a 7 segment display. So how to operate the 7 segment display? Let's take a look at the next slide. Okay, so this is the logic symbol for BCD to 7 segment decoder with active low output. So you can see here, the output is active low because of the bubble. Okay, so in BCD to 7 segment display decoder, it has a total of 4 inputs, which is BCD input. We give BCD digits to the input here. And then we have a total of 7 output, which is directly connected to the 7 segment display. So in 7 segment display, we have 2 types of display. The first type is common anode and the second type is common cathode. So this is the common anode, what we call a 7 segment display. So for common anode 7 segment display, we already give the supply of the voltage to the common anode. So what we need to do is we need to give the ground connections to operate. So our BCD to 7 segment decoder IC need to give the ground signals to the 7 segment display in order to light up each and every segment to give a specific output to the 7 segment display. So in common cathode 7 segment display, we already supplied the ground to the 7 segment display. So what we need to do to operate the 7 segment display is we need to supply the voltage. So in this situation, we need an active high output of 7 segment decoder in order to operate the common cathode 7 segment display. So for common anode, LED on when low input is applied to the 7 segment decoder, and LED on when high input is applied from the 7 segment decoder. Okay. So next, we go through about the 74X47 IC, which is the BCD to 7 segment decoder. So the 74X47 is the example of IC device that decodes a BCD input and drive the 7 segment display. So this IC, it is used to decode a BCD input. We give the input of BCD and it will decode the input and it will use to drive the 7 segment display. So this type of IC, is a common anode display. So it means that we need to give the ground connection to the 7-segment display in order to operate the 7-segment display. Okay, this is the connection diagram for the 74X47 IC. So it has a total of 16 connections. So the first connection is pin 1, which is the BCD input A1. The second pin is the BCD input A2. And the third pin is the lamp test. The fourth pin is blanking input, ripple, blanking output. The fifth pin is the ripple blanking input. D is BCD input A3. A is BCD input A0. And the pin 8 is the ground. The pin 16 is the VCC. And the other pin is the output to be given to the 7-segment display. So in this lesson, we will not learn about the extra features of the 7-segment decoder, which is the lamp test, blanking input, ripple blanking input. So we will learn about the other important features, which is how we want to operate the 7-segment decoder. Okay. So this is the logic symbol of the BCD to 7-segment decoder, and the output will be directly connected to the 7-segment display. So you see here, the 7-segment display has its own sequence of letters. You see here we have A, we have B, we have C, we have D, we have E, we have F, and also we have G. So you need to remember the sequence of each and every letters in order for you to not get confused when you answer the question inside your test or inside your final exam. And sometimes the 7-segment decoder, the 7-segment display also have the decimal point, which is connected to the extra pins inside the BCD to 7-segment decoder. So the function of the IC is to convert a 4-bit BCD A3, A2, A1, A0 to 7-segment LED, which is represented by A, B, C, D, E, F, and also G. So this is the truth table for the BCD to 7-segment display code. So actually you don't have to remember the output of the 7-segment display code, but you just need to remember the sequence of the letters so that you will be able to figure out what is the output for 7-segment display code. So in order for you to know what is the BCD codes that represent the decimal value, you can just convert directly the BCD number to the decimal number. For example, in BCD 0001, in BCD it represents decimal value 1. So for this type of BCD, it will display number 1 inside the 7-segment display. Okay, for 7-segment display, the segment turn on and off to display different numbers. So in order for the the 74X47 IC to turn on the display, you need to give 0. And in order for the segments to turn off, the decoder must give 1 to the 7-segment display. Okay, for example, for decimal value of 0, the BCD code is 0. So you see here, the 7-segment display code is all 0 except G. G is 1. It means that we will turn off G. Okay, when we turn off G, the digit will become 0. So next example is the number 1. So for number 1, the BCD code for number 1 is 0001, and then converted into decimal, it will become 1. And then for 7-segment display code, the first one, A is equals to 1. It means that A is switch off, and then B is turn on, C is switch on, D is switch off, we switch off D, and then we switch off E, F also, and we switch off G. So we get the digit 1 inside the common anode 7 segment display. Okay. So next example is number 2. So for number 2, the BCD number that represent number 2 is 0010, and then if you convert into decimal value, it will become 2. So for 7 segment display code, you can just get the output. You see here, A is 0, it means that A is switched on, B is 0, B is also switched on, C is 1, so C will be switched off. Okay, D is 0, D is maintained to be on, E is also 0, so E is switched on, F is 1, so we switch off F, and it will become number 2. So this, what we call a cycle, continues until it reach number 9. So when the BCD code is 1001, we convert into decimal, we will get the number of 9. And then for 7 segment display code, all the 7 segment display code is switched on except code E. Okay, except for the letter E. So the letter E will be switched off because we give 1. And then it will become number 9. Okay, so this is how you want to operate the BCD to 7 segment decoder by using 74X47 IC to the common anode 7 segment display. Now, let's take a look at the example question given for BCD to 7 segment decoder. So in this example, a 7 segment decoder drives the display as figure below. If waveforms are applied as indicated, determine the sequence of digits that appears on display. So in this example, you are given a timing diagram with a total of 1, 2, 3, 4, 5, 6, 7, and 8 different segments. And you are also given a BCD to 7 segment decoder with active low output. So the question asks you to determine the sequence of the digit that appears on the 7 segment display. So how to determine? Let's take a look at the answer. So, in order to determine the sequence of the digit appears on the 7 segment display, we must know what is the BCD input which has been connected to the BCD to 7 segment decoder. So after we determine the input BCD, we can compare the BCD input with the truth table that indicate the 7 segment display output. So for the first segment, it shows a number of 1000. But which one is MSB, which one is LSB, so that we will be able to compare the BCD code to get the output. So in BCD number, we have each bits of number has different weight. Okay, so for example, A3 has a weight of 8, A2 has a weight of 4, A1 has a weight of 2, and A0 has a weight of 1. So in order for us to know what is the correct sequence of the BCD input, we can just get the reference from the weight. So for the weight, A3 has the highest weight, so it indicates A3 is the MSB and A0 is the LSB. So the arrangement of the BCD number has become A3, A2, A1, and A0. So it has become 0, 0, 0, 1. So after you get that number, you can compare it to the truth table. So the decimal value which is appeared on the 7 segment decoder is 1. Okay, so the first answer is 1. So next, let's move to the next sequence. So next sequence shows A0 equals to 0, A1 equals to 1, A2 equals to 1, and A3 equals to 0. So after we determine the correct sequence of the BCD number, you will get 0, 1, 1, 0. And then you compare with the truth table, 0, 1, 1, 0. You can get the number of 6. So number of 6 will appear inside the 7 segment display. And your next number will become 6. And then we go through to the next segment, which is 1001. So after you determine the correct sequence of the BCD number, you will get 1001, which is from A3 to A0. Okay, so you compare with the truth table, you will get 1001 in BCD equals to the decimal number of 9. So it means that at the 7 segment display, a number of 9 will be displayed. So the answer for the next sequence is 9. Okay, so you repeat the same procedures for the next segment and you will get 4, and the next segment you will also get 4, and the next segment you will get 4, and the second last you will get 8, and at the last segment you will get a value of 0. So this is the way you can find the sequence of the digit appears on the 7 segment display by referring to the timing diagram. But you must remember, you need to know what is the arrangement of the BCD number so that you will not get confused and your answer will become correct. So that's all for today's class. Thank you.